All right, let's look at the Unit 5, Lesson 8 practice problems for homework. This is in your Algebra 1 Illustrative Mathematics curriculum by Imagine Learning. There are 8 examples in Lesson 8. First one is much like the task we just did together in class. For an experiment, a scientist designs a can that's 20 centimeters in height that can hold water, and a tube is installed in the bottom of the can, allowing water to drain out. At the beginning of the experiment, the can is full. When the experiment starts, the water begins to drain, and the height of the water decreases by a factor of 1/3. Decreases by a factor of 1/3. So that's already telling us what our factor is. Explain why the height of the water in the can is a function of time. And so again, you're just putting that whole concept of for every x, there's only one y. You're going to put this into a context answer. For every blah, there's only one blah based on this. So for every height, let's go to the time first. For every, is this hours or minute? So just like saying for every input, there's only one output, we're saying for every minute, that's our inputs, there's only one height, that's our output. And so next B, this is a function of time. Find an expression for f of t. So they're giving us a name for this function, f of t. And it begins with 20. And it's got a factor of 1/3. And so that's the power of input of t. Find and record the values for when f is 0, 1, 2, and 3. So you're going to plug in f of 0 to the function to your calculator, 20 times 1/3 to the power of 0. Get us that answer. You're going to plug in 1, 20 times 1/3 to the power of 1. Get us that answer. Plug in 2, 20 times 1/3 to the power of 2. Get that answer in your calculator, and then plug in 3. 20 times 1/3 to the power of 3. Get all 4 of those outputs. Finally, get f of 4. Plug in 4, 20 times 1/3 to the power of 4. Get that answer, and then what does it mean? Well, that would mean at 4 minutes, the output, the height, is blah, 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 whatever you got. So you're going to write me a sentence for part D that says at 4 minutes, the height is, and then whatever you get for this answer right here. Sketch a graph of f. So this is starting when you plug in 0 at 20, and then it's going down 1/3. So it starts up here, 1/3, 1/3, 1/3. You'll get a decreasing function like that. What happens to the level of water in the can as time continues to elapse? How do you see this on the graph? The level of the water is decreasing exponentially. Number 2, a scientist measures the height of the tree and the number of months. Is the height a function of the month? Explain how you know. Is the month a function of height? So you're answering yes or no based on this scenario and then giving me an explanation. Yes or no, and then giving an explanation. Bacteria population is 10,000 and it triples each day. Explain why the bacteria is a function. So again, for every input, there's only one output. You're going to put this in terms of context. For every amount of days, there is only one amount of the bacteria population. Which variable is the independent variable in this situation? Independent is the amount of days. And then write an equation. So the bacteria population begins at 10,000, is tripling times 3 based on the number of days. Number 4, is the position P of the minute hand on a clock a function of time? Yes or no? And give us a reason why. Is the time a function of the position of the clock? Yes or no? And give us a why. The area covered 20 miles. The area grows by a factor of 1.1. So again, for every input, there's only one output. You would convert that to context. For every amount of years, there is only one area. And then write the equation. Area begins with 20 square miles times the factor of 1.1 to the power of t. This graph shows the exponential relationship between x and y. Write an equation. So this begins at 50, and it goes from 50 to 100, from 100 to 200. Do you see that that's times 2? But if you're not sure, do 100 divided by 50, do 200 divided by 100, and get that factor of times 2. It's doubling. And then to the power of x. What's the value when x equals -1? Well, if it's going forward times 2, to go backwards is divided by 2. 50 divided by 2 is 25. And that's a y. You can also plug it into the equation, 50 times 2 to the -1. What's the value when x equals -2? 25 halves. Because again, we're going back a step right here to half of 25. This is going way back to last semester, where it's asking you to solve this and then graph it. And so here we're going to add the x's to get 7x's. And then -1, we're going to get 7x's is greater than 33. So we're getting 4 point something. Do 33 divided by 7 on your calculator. 4.7, something like that. So this is going to be an open dot at 4.7. And then we want to shade greater than. Do you remember these? Greater than would be in that direction. Finally, here are 3 equations that define 3 functions. They're asking you to plug in 100 and evaluate and see which has the greatest value when you plug in 100. So this one's going to require a lot of work on your part, showing work to get full credit for this. So please plug in that 100 and let's see how it comes out. And then you'll just highlight whichever one is greatest once you plug in 100. So putting in 100 divided by 4. Okay, so here you're plugging in 100 to all 3 of those functions and then seeing what you get. Highlight the one that's greatest. Which one is the greatest? Plugging in -100. Do it again with a -100. Which one is the greatest? Plugging in 1 over 100 or plugging in 0.01. Which one is the greatest when you put that in? So this one's going to require a lot of work. Show me all those solutions and then show me which one is the largest of the 3 for each one. All right, thanks so much. Good luck on homework.